Today's lesson is 10.1, Area of Rectangles, Parallelograms, and Other Figures. The base of a parallelogram are any of the sides, because when you rotate your parallelogram, any of those sides could become a base. The altitude, or height of a parallelogram, is the segment that is perpendicular to the base. So let's go and look at some of these figures. This is a worksheet I pulled up. This is not in your notes. It says draw an altitude to the bottom of each side for the figure. So let's define what the base is. So right here, this will be the base because it's the bottom. This will be the base. This will be one of the bases, and this will be the base. Then we have to go in and draw the altitude. So we have to be perpendicular. We'd have to be perpendicular. We'd have to be perpendicular to the pink, and then here we have to be perpendicular to the pink. So maybe I'll go ahead and draw that a little bit thinner here. So from here to here, we just have to make sure we'd be going down at a 90-degree angle. So that would be our height. So the height is the orange distance, making sure that again we have a right angle. So that is what the altitude is. Areas for rectangles and parallelograms. Area equals base times height. So in a rectangle, that's plain and simple, base times height. It doesn't matter which one is B and which one is H because multiplication is commutative. And then in the parallelogram, we also have base times height. And here's the reason for that base times height. If I take this triangle and I move it over here, then it becomes the other part to turn it into a rectangle. And then of course, this piece would then disappear. So then it turns into a rectangle. So that's why base times height works for a rectangle and for a parallelogram. Find the following for the two parallelograms. So in parallelogram 1, we're going to find the base, the height, the perimeter, and the area. So we're going to define the base as being 5, because it's the bottom, and then the height is the perpendicular distance, so that's the 4. So then if we had to find the perimeter, we have a 5 and a 5 for 10, a 4.5, and a 4.5 for 9. So we get 19 for our perimeter. Then we need to find our area. Formula for area is base times height. So we're looking at 5 times 4. Area is 20. And that would be 20 square inches. So perimeter would just be inches because we'd be walking on these blue segments. And area would be square inches because we're talking about the space in 2 dimensions, length and width, or base and height. In the second example, our base we're going to consider to be the 2, and then the height is the perpendicular number, so that's going to be the 3.5. So to find the perimeter, remember we're just going around the object, so 2 and 2, 4.6 and 4.6. So then our perimeter is 13.2. Then for our area, we want to do base, which is 2, and height, which is 3.5. So then our area is 7. Let's try it with a more complicated shape. For ABCD, find the length of DE to the nearest tenth. So we want this height of that parallelogram. So there are some other dimensions in this shape to help us do that. So what we're going to do first is find the area of it, because I see that we have a base if I rotate that shape, and then our height would be the 9. So let me show you what I'm thinking. So if I turn the shape like this, then my base is 13 and my height is 9. So our area equals base 13, height 9, which gives us 117 square inches. So now if I turn the shape back, rotate it, I can use that 117 to find our missing dimension. And here's that missing dimension. I'll call it X, because that's what our DE is. So now, area is 117. That has to equal base 9.4 times that X value. So I'll divide 117 by 9.4, and I'll get 12.4. And that is a length, so I'm just going to write it as inches. Let's move on to triangles. Formula for area of a triangle is 1/2 base times height. From middle school, some of you might remember as base times height divided by 2, and this is the exact same formula. The base and the height always have to be perpendicular, and the base is not always going to be the bottom of the triangle. It just depends on how it sits. So here are some examples. Here's a triangle. We're trying to find the perimeter and the area. So let's define what our base is first. Remember, our base and our height have to be perpendicular. So I think we're going to define our base as being 5. And I guess I was wrong. I defined it as 12. But it doesn't really matter which one is base and which one is height, as long as they are different. And then to find our perimeter, we're going to do 12 plus 5 plus 13 for 30. So then our area is 1/2 of our base times our height, and that gives us our 30 square meters. In the next example, we're going to use 12 as our base. Our height has to be perpendicular, so our height is the 10. But now we're not going to use the 10 to find our perimeter. We have to use another method. So I have to figure out what this side is to calculate that perimeter. So I'm going to use Pythagorean theorem here on this mini triangle. So I get x squared equals 10 squared plus 3 squared. And I'm just rounding to the nearest tenth, so I get 100 plus 9, the square root of that. So I'm getting about 10.4 for the orange. So then if I add 10.4, 12, and 8 together, that gives me the 40.4 centimeters for the perimeter. My last step is to find the area. Remember, area is 1/2 base times height. So we have 1/2, base is 12, height is 10, for 60 square centimeters. We will skip the next slide. Find the area of the entire figure. So on top we have a triangle. And on the bottom we have a square. Area of a triangle is 1/2 base times height. Formula for a square is base times height or side squared. So in our triangle, our base is 6 and our height is 8. And the area of the square is 36. So when I work this out, I get 24 plus 36, which gives me 60 square inches. So finding the area of the shapes separately and then adding them together. Let's look at some shapes in the coordinate plane. ADKF. So ADKF looks like it's a parallelogram. Slope of the top and the bottom would be 0. Slope of the left and the right looks like it would be up 1, 2, 3, forward 2, so 3 halves. Up 3, forward 2. So yes, this is a parallelogram because opposite sides are parallel. Find the area. So if it's a parallelogram, we're doing base times height. So we're starting at 1 and going over to 10. So looking at the coordinates, from 1 to 10, I would say that's 9 units long. And then the height, remember we have to be perpendicular, so that's going to be 3. So the area of that orange parallelogram is 27 square units. Now we need to find the other shape, triangle BCJ. So this pink triangle. Formula for a triangle is 1/2 base times height. Using the coordinates, looks like my base is 2, and my height is the same as the parallelogram, 3. So the area of that triangle is 3 square units. This concludes my lesson for 10.1.